I've talked previously about naming ionic compounds, and now I'm going to talk about naming covalent compounds, or also known as molecular compounds, as a comparison to the ionic compounds. So the main difference between them is that in molecular compounds, the name needs to indicate how many atoms of each type there are. Notice, you may recall from ionic compounds that unless it was a metal atom, such as iron, that had more than one charge possible, you didn't need to indicate counts at all because you can figure it out from the formula. But that's not the case with molecular compounds because of the law of multiple proportions, which says that we can have carbon and oxygen in a 1-to-1 ratio as a compound, and we can also have carbon and oxygen in a 1-to-2 ratio. And so we need to have a naming system that tells us the difference between the two. And you may know that carbon with an oxygen is carbon monoxide. The same thing you find in your detectors, the same thing that your detectors at home are detecting for. And then CO2 is carbon dioxide. So notice there is a prefix in front of the oxygen that indicates how many of them there are. And also notice that they do still have the IDE ending on the second part of the name. And the first part is just the element, except if there's more than one. Okay, so the prefixes are given down here, where mono means 1, di means 2, tri is 3, tetra, penta, hexa, hepta, octo, nona, and deca, okay, for up to 10. All right, so the basic rule is that the first element, in the example above, is carbon. Whoops, didn't mean that. The first element only gets a prefix when it's not mono. Okay, so then it's not 1. So we generally don't use the mono in front of the carbon. But for something like Cl2O6, you would need to use the prefix in front of the chlorine. So it would be di, which means 2, chlorine. Okay, the first element does not get an IDE ending, it's just dichlorine. And then the prefix for 6 is hexa, and you put oxide. Okay, and some books differ on whether or not you should put an A with an O, the two vowels together. Some of them will have you drop one of them. Either one is acceptable. So that's general rules for naming molecular compounds. Now we're going to need to do some practice so that we can see the difference between ionic and molecular compound naming. So let's practice a few. So you look at a compound, the first thing you need to do is decide which set of rules you use. So look and see if there is a metal. If there's a metal and non-metal, then that's an ionic compound. You need to use ionic rules. So this first one has a metal, copper. The second one has a metal. The third one does not. Okay, so the first two are ionic compounds. You need to use those naming systems that we talked about. Let's do the middle one first. If it's a metal that only has one oxidation state or one charge, then you simply name the metal and you name the anion with its IDE ending. No need for a count, okay, because we know that zinc has a 2+ charge, and it always does. All right. However, copper can have a 1+ or a 2+, and in this case, we look at NO3- and we recognize that as a polyatomic ion, nitrate. So we know we'll use the name nitrate, plus we know its charge is -1, and since there's 2 of them, at -1, we know the copper must be the 2+ form. So we would name this copper 2 nitrate. Again, we don't have to indicate the number of nitrates because the copper 2 lets us know what that is. All right, let's go to the third one. This is all nonmetals. and there are no polyatomic ions in there. So if you saw a polyatomic ion, it would be the ionic rules, but there aren't any. So we use the molecular rules I just talked about. We list the first element, phosphorus, and we don't need a mono in front of it because it's the first element. And the second part would be indicate, we do need to indicate there's 3 fluorines, so it'd be trifluoride. All right, try practicing some of these in number 2 before you continue the video. Tin 4 chloride, the symbol for tin is SN, and since there's 4 plus, we know that there has to be 4 chlorines because chloride is a -1 anion. All right, dinitrogen, that's 2 nitrogen. Pentaoxide, that's 5 oxygens, N2O5. Sodium oxide, we put Na together with O2 minus, so we're going to need 2, whoops, too late. Write it again. So we're going to need 2 sodiums for 1 oxygen. Lithium, the last 2, lithium nitride and lithium nitrate. You have to think of what the difference is there. I'll do lithium nitrate first. Nitrate is a polyatomic ion, NO3 minus, and it's a single minus, so it matches 1-to-1 with lithium. Nitride refers to the element nitrogen. It's not a polyatomic. And since nitrogen will take a 3 minus charge when it's an anion, you're going to need 3 lithiums for that. Okay, and finally, look at these compound names, proposed compound names in number 3, and there are 5 errors in these names. So stop the video, see if you can find all 5, and then I'll let you know what they are. All right, so in the first one, the problem is that chromium is an element that needs, has more than 1 charge, so we know that in this case it's a 2, could be a 2 or a 3, but if it's 1-to-1 with oxygen, it must be a 2. The second one, this is a recognizable polyatomic ion, so it's not nitrogen trioxide, it's nitrate. Mononitrogen bioxide, we don't need the mono in front of the first element, and it's not bi, it's di for 2. And finally, diphosphorus pentaoxygen, you need to change the ending to IDE and make it pentaoxide.